And welcome back. Now today's going to be a rather special video because we're not going to talk about hardware like this today. What we're going to talk about is how we manage our code whilst we're writing stuff for this. Can you guess what the topic is? Bit of a clue, I suppose, isn't it? Right, let's talk about libraries and how it can really help you once you've got a decent bit of code under your belt and you're drowning in lines of code. So the first question to answer really is, why would you even want to create a library? If you're quite happy creating a sketch like the one shown on screen, you think, well, this is fine, I'm just going to put all my stuff in this one file. I'll even separate it, of course, into separate functions and so forth, but I'll keep all my code here. And yes, you can do that, and I do it all the time. Of course, I don't create libraries for everything, not by any means, but a library can be useful if you've got some complicated or verbose methods or functions and you possibly want to use them again, or even if you don't want to use them again, frankly, just get them out the way. You want to put them into a different file that you can then use within your main one. So for example, if you've got a sketch that might monitor your beer fermentation process, I'll only use that as an example because I know somebody at work does just that. Now, there's going to be many functions that are going to be used in that sketch. You know, you're going to be looking at temperature, you're going to be looking at time, you're going to be looking at different kegs, all sorts of different things. And you can imagine that the sketch could become quite verbose and unwieldy, in fact, so that when you're looking for a particular method that you're trying to change, you've got to scroll up and down a lot in your file. You're not quite sure where it is. You might end up collapsing a few sections, if you notice on here. You might, for example, collapse your code to try and get it out of the way of the code you're actually trying to write. So on here, for example, this simple little sketch, if you click that little minus, it will collapse it and keep it out of the way. I often do that with the setup, because once you've got the setup done, you don't want it constantly at the top of your IDE getting in the way. And that's one way of doing it, of course. But it'd be so much nicer if you could create your sketch, get to a point where it's stable and you think, right, I don't want to touch this anymore. My temperature monitoring function, for example, is quite long. It reads from various sensors and it gives me something back. And that's it, it's done. And I want to continue writing the main sketch now, but without that constantly getting in the way. So this is how we're going to put some of that code into a library out the way that you can include in your sketch, and indeed include it into other sketches. So if you've got a more generic function, then you can include that in as many sketches as you want. But let's start with the basics and say, right, here we have your brand new open file that in fact I have saved as library example number 1, and I'm just going to create a very simple made up function. Now, what I don't want is for you to watch me type in rather painfully some code in these sections here. So I'm going to put a little tiny nonsense sketch in here that basically doesn't really do anything except print a number, say. But we're going to pretend that the method or the function that it calls is quite long and verbose and complicated, and you've done it and you don't want to do it again. So let me just paste in that code first and then we'll talk through the rest. Oh, Benny's going to come and supervise with the sounds of it. Right, so here we have some very simple code, but we're going to pretend it's not so simple, and then we're going to pretend it's a bit longer and more verbose and generally complex than what it is here. So what we've got here is basically a main loop that calls an underlying clever function that you've written. It's taken a long time and it might call many other functions within it, and then you're just going to print a number on the screen. So for our demo purposes, it's particularly simple, but that's good because then you can see the wood for the trees. So here is this complex function that you've designed. It's probably 20, 50, 100 lines long maybe, and it returns a special number that is meaningful to you as part of your beer monitoring process or whatever it happens to be. So having got that ready now, and you think, right, now I want to write another function under that. Now this one's all in the way a bit. Well, yes, as I said before, you can collapse it like that, but you still get something there. So what we're actually going to do is take this single function here and put that in a library, and then see how you have to change this to include that in your program. Now, of course, if you've written any sketches at all of note, you probably have used the include statement with a library. It's just that if you've ever looked at a library behind the scenes, it can seem quite daunting and complex. So let's unravel all that and make it really simple. So the first thing to do is, of course, create what is the stub of your library. Now, a library has 2 files in it, well, more than that actually, but we'll discuss those going forward. 2 main files. There's the .h, which is the header, and .cpp, which stands for code program, something or other, but it's the code. It's effectively the CPP stuff is going to contain all this, and your header is going to contain a description of what this is and allow you to create something so you can get hold of it. So let's do that. Now on the Arduino IDE, and I'm deliberately using the Arduino IDE here because it's what most people use, and it's just as simple to create a library in here as it is using any other IDE. Okay, right, the first thing to do is what? Let the cat out. Right, okay, so what we do, we click on the little triangle there, and you can see the little pop-up comes up, and we want to say new tab. Now what this is actually going to do is create a file in the same place that you created your sketch originally. Now that's no good for a library going forward, but it will certainly be good while we're testing it because it'll be local to your sketch. So we're going to create 2 tabs and the name. Now let's assume that we're going to create a test library. So let's call it test library header, and another one which is the test library .cpp. These will be saved in the same place as your original file, as I said, so that's good. There is a small tiny caveat, is that when you include it, it's very easy to find files in the same folder, not so easy to find files in the libraries folder, so you have to use angle brackets, not the quotes around your library. So let's have a look how we might do all this. Right, first of all, we want to take this long process here and put it into the CPP, because that's where your code is going to reside. So that's the first thing we can do. So we can take all this, simply cut it out of there and put it into here. Okay, we're going to do a bit more to that in a minute, but at least it's got rid of the stuff out of your standard sketch. Now the next thing is to update the header. Now you're going to have to trust me on this one a little bit, because there's a few things in here that just are the way they are because they are the way they are. Now assume that you write your test library and it's a great success and you think, great, I can include this in all my programs, and unknown to you, you've actually tried to include it more than once. You've got a series of files and you've included it in one sketch, and then you've included it perhaps in another library even. What you don't want to do is include it twice. That will give you compilation errors because you get duplicate references everywhere. So the first thing you need to do is to say, if I've already got a copy of this file somewhere, don't include it again. And the way you do that is to have an if not defined, if endef, and then whatever you want to call it. So we're saying test library, let's keep this short, TL. So if we haven't defined it, then we will define it. And then right down the bottom of all this, we're going to have an end if. So everything in here that you're going to declare as part of your header will be subject to this if statement. Have I already got this somewhere? In other words, can I find a reference to TL? No, I can't. Great, I'll include it. Now, if you were to include it twice, then the second time it hits the test library reference, wherever it may be, you'll go, if it's not defined TL, oh, but it is defined, I can see a reference to it. You'll just skip to the end if, and that'll be it. No compilation errors. Cool. Okay, now there's a standard thing that goes at the top of every header, and basically it says, if my Arduino version is greater than 100, which is basically 1.0, then I need the Arduino header. So we're using a library already within our library. So if you want to use Arduino functions and names and stuff within your library, which you will, then you need to include the Arduino header specifically. Your sketch does that behind the scenes. You don't have to do that. You may have noticed when I use my Eclipse IDE, I have to include it explicitly because it's not specifically for Arduino use. It's for lots of languages. So let me just paste that in, and then we'll come back to that. Okay, so that's pretty standard. So here I've pasted in the rather simple class definition, but let's just go through this line by line. What we're saying is here, we're creating a new class. Now, a class can be considered a blueprint. Okay, it's not the actual object you'll be working with in your sketch. You're going to have to instantiate that. That means create an object from this blueprint. So that's what a class is. We're saying, right, let's create this test lib. I've called it test lib. Normally, I think you'd tend to probably call it the same name as the file it's in. So like test library, but it's just a bit long, isn't it, for us at the moment? So I'm calling it a test lib. Then we say, right, which functions do we want available publicly? That is, that you can call from another program. Now here, the only two public methods we've defined is one is the constructor. That is, this is called when you declare this use. We'll go through that in just a second. So here we're saying, here's the constructor. When you create this type of object, this is the thing to run, and I'm declaring it here but not telling you exactly what I'm doing with it yet. And we've got a method called getRandomNumber, which is the bit of code that of course we've half-inched from the main sketch, and we're going to put that into the CPP. Now you can also declare here some private methods. What are private methods? Well, they are methods that you can use in your CPP by the CPP itself and which are part of this library, but which cannot be called from your main sketch, and nobody else can call them from their main sketch either if you were to share this library, for example. So they're private to the class. The class itself can call them, but they're not exposed to the wider public, if that makes sense. Okay, hence public and private. Now within private, you can't just have methods. You could have variables, for example. So if you wanted a count or something that you want to keep track of, you could declare it there. Okay, well that's all we're going to do for the class, and as you can see, it's very simple. Oh, one warning here, please end it, as you can see here, with a semicolon. I've spent many an hour trying to figure out why this thing wouldn't compile or that thing wouldn't compile, because you've forgotten this semicolon, and guess what? The compiler doesn't tell you. It just gives you a zillion errors about, oh no, something wrong with the name or something. So don't forget that semicolon at the end of your class constructor. Right, let's move over to the CPP library then. Right, this is the CPP, and all I've included in here at the moment is this rather weird construct. Now, if you remember, in the constructor of the header, so we flip back here, we're saying, look, here's the constructor, testlib, and we have a boolean and whether or not to display a message. Well, I'll just put this in there just to show you how you can pass messages in. In fact, let's enhance that, because you might want to, when you create this object, you might not want to always say display a message. So what you can do there, in fact, is put a default parameter. So do we want to display the message always? No, we don't. We might want to do it when we're debugging something, but not always. So we can say, no, don't display it by default unless you've included a parameter that says, yes, display a message. So in our, and this is where you do it in the header, don't do it in the CPP bit. So in the CPP file, we're saying, right, of the testlib class, here's my testlib constructor. Look at the colon bit in the middle. Do you know, I'm sure they do it just to make it look complicated. Anyway, so there's the class, it's the constructor. Here's our little parameter that we're expecting to come in, but if you don't supply it, it will get the default value of false, right? And as it happens, we're not actually doing anything yet with it. But you could easily here do a serial.print, assuming that the serial port was open. Anyway, it just shows you how to supply a message, or a parameter, I should say. Now, here's your pretend long complex procedure that we pinched from the sketch. Now, here you can't just leave it like this, because this getRandomNumber doesn't say it's part of the class. So once again, this little bit here, test : we're going to have to put in there as well. So let's just put that in. There we are. So now it knows that this getRandomNumber is part of this class, as is the constructor part of this class. Brilliant, it's all hanging together. So if we look at the header again, we're saying, here's my constructor called testlib, which is the same name as the class, it has to be. And here's my single function that I've got, and no, I haven't got any private functions yet. Okay. So back in our library example now, we now include a reference to the test library. Now here you notice is in quotes. Now if you move your library files to the libraries subfolder, then you're going to have to change that to angle brackets. But because it's in the same folder, we'll leave it as quotes, because otherwise it might not find it. Quotes means same folder, angle bracket means the wider scope. Okay. Now we're declaring testlib. Now you'll say, where's this testlib come from? Well, that's what we called it when we declared it. Look, class testlib. Now you could have had any name in there. Fred, John, super complex name. Keep it simple there. Okay, so that's what we need to use as the type. Now the name of it can be absolutely anything you like. Fred, John, anything. But just for demo purposes, we're just calling it the same in lowercase. Now remember we said we had a parameter. All right. Now we've made it optional, so if we don't specify anything here, you won't get a message coming out. Well, if we'd written the bit of code that would put the message out. But we're saying yes, in this instance I'd like that message to come out because it'll tell you as a developer, oh, it's actually called the constructor of my class. Okay, so when this bit of code runs, this bit here, so it is actually instantiating the object, creating the object from the blueprint. You could put a serial.print in here just to say I've run, or the testlib object is now being created. Okay. Now, okay, that's fine. So all the rest of the code is as it was until it gets down to get random number. But of course, that's now a function of this object, which is here. Okay. And as a function of this object, it's dot get random number. And that's it. So simple. So we've taken this get random number, quite complex, well, pretending it's quite a complex piece of code, maybe several methods that it might be calling itself. We've taken it out of your main sketch, stuffed it into a CPP file and said yes, now it is actually part of this library, testlib library, and the header has declared it here, and it's made this sketch very, very clean and easy, just like it is when you use other people's libraries. Your sketch is now nice and lean. However, don't get carried away here. Don't think, so I've now got more space to put more code in and stuff it into my Arduino. It doesn't work like that. No, no, no. Your code size is this sketch here plus this library. It all gets compiled. Now, I'm pretty sure the compiler isn't smart enough to dispense with methods that aren't used. I think it all gets compiled. An optimizing compiler, for example, would come to your library and say, do you know what, you haven't actually called this routine anywhere. I won't even compile it. I'll discard it. I'll compile all the ones you have used, but the ones you haven't, I'll discard. I don't think the GCC one does that. So the size will remain the same. It won't be any bigger though, because although we've written 3 files now, more text, if you like, the actual underlying code will stay the same. Right, that's all it is to do. Let's compile it and see what happens. Well, that took a few seconds longer than I expected, but there it is. It's come back, and it says the sketch uses 24884, 9%, blah blah blah. So it says it's run or compiled. So let's upload it then to the Nano that I've got attached on my desk. Of course, the actual Nano itself isn't going to show anything, isn't going to do anything other than spit out a number, the number that we created as part of the CPP part, this one here. Okay, so let's just upload that and then see what comes out on the debug window. Here we are. Right, so there's the debug window. Let me move that up here. And there it is, spitting out the number. So what we're doing, of course, can I make this any smaller? Let's have a look. Yes. Right, so this is saying, go and get me my random number generator function from this library, and if somebody else wrote this, say a friend wrote the library and gave it to you to use, you might not have any idea how this works, and frankly you might not be that bothered. It's sort of a black box, isn't it? But work it does. So you're getting this random number back from the test library, which this object here, the testlib, has been declared here, and it's of type testlib with the capitals. Okay, and that is all declared in the header. Here's the test lib constructor. There's the method that's actually doing the work. So let's see then if we can actually put in a message in the constructor, so that up here basically. So when we instantiate this library, we actually get a message back to the serial port saying, yes, I have actually run. And in the meantime, while I'm doing that, I'm going to clear up whatever's causing this. It's probably some old library somewhere it's trying to find. Anyway, I'll do that and come back in just a jiffy. Now, interestingly enough, I'll remember that there's a little gotcha here. If you can see the screen at the moment, it's supposed to be outputting a message here as part of the constructor. And in fact, if we just flip over to the constructor of this, what it's supposed to be saying is test lib constructor instantiated blah, 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 blah. And we've done a serial.begin here, because obviously we're going to need that if we're going to output a message. And we've taken it out of here. However, there's a little gotcha here. If you start putting serial.begin in constructors, it doesn't like it. Don't know why. The forums aren't any help in saying why. What they do say is, though, put this into a different method. So we create another method or function on our test library called begin or something, and put any messages like this in there. So let me just change this about a bit. We'll have to change the test library as well to say there is a begin function now that we can use, and see how that comes along. Okay, very simply then, all we've done now is said, look, as part of this test lib, we're going to give you another method called begin. And while we're at it, because we are going to do a serial.begin in there, let's give it the baud rate that we want the serial.begin to start at. And here's the default value, 9600. I use 9600 all the time. But I have to put serial.begin 9600 everywhere because that particular library hasn't got a default value. But we're going to be kind to our users and say, well, the baud rate, which is a parameter to the begin method, has 9600 as a default value. So if you don't specify it, that's what you're going to get. So now our CPP library has to actually create that method properly. And I've squeezed it in here, look. So test lib, remember it's got to be part of the test lib. You can't just have a begin, because it could be a begin for any class, and lots of classes have got begins. So we're going to say test lib begin. Here's my baud rate. Okay, remember we don't put any default parameter in the CPP, it's always in the header. So serial.begin, whatever you've said, and then we can print out our line. And we've taken it out of here. We'll come on to this display message in just a minute. I want to get this bit clear first. So now in our sketch, we're going to say create the object as we always did up here. And then instead of doing a serial.begin, we're going to say testlib.begin. So that will do effectively a serial.begin 9600 and display a message. So let's see if that works. Let's upload that and see what happens. There we are, it's running nicely. Got the message coming out, and the pseudo random numbers are coming out as well. This is a ultra long complex procedure, remember, doing all this, calculating the number of stars in the galaxy or something. So that's all pretty good, isn't it? But one little fly in the ointment, this message that comes out, we might not want that coming out every time. So only when we want to debug something do we want that message coming out. So how do we stop it? Well, remember that when we do a test lib up here, when we create the object here, we're saying true. Yes, we do want it out, but if we don't put something in there or put false in, it shouldn't come out. So if I just change that to false and upload that and have a look at the output monitor, serial monitor, right, it's done it. And oh dear, it's still coming out. Why is that? So remember when we changed the way that the serial.begin was being invoked by our little object called testlib, we didn't change anything in here. This is where it's saying, do you want the message coming out or not? But we've not done anything with it. So of course here it's going to print it regardless, because there's no if statement around there. Now this is a very good example now I can show you of how to use private variables. This display message, when we instantiate the test lib, is the one that controls whether a message will be output or not. But how are we going to keep track of what that value is? We don't start putting globals in here. So in the class lib definition, as a private variable now, we can put in whether or not we want that message shown. So we have a private. Now if you notice, it starts with an underscore. That's a convention for all private variables, so that in your code you know you're dealing with a private variable, not exposed to the real world. By that I mean in your sketch. So in here, there's no way you can get hold of that underscore message boolean. It just isn't available to you. None of this can read it. It's only available to this here. So what we're going to say here then is we're going to say underscore message equals display message. So we're capturing the value of this when it's instantiated, storing it in our private variable, and then here we can say if underscore message. Now we don't actually need the curly braces because it's a single if, but to be quite honest, so many people get things wrong when they don't put it in. I think we will. Right, format that, Control T. Right, so what it's saying is if we set it here, true or false, we'll read it here. So this is acting like a sort of global variable, but it's in our class definition as a private variable. So now, without changing our sketch, let's compile that, upload it and see what happens. And there we are. It started to print out the numbers without that message. And just to prove the point, if we change this now to true and re-upload that and bring this window to the fore, uploading, it's done it, and there we are, it's back again. So now we control whether that message is available, and effectively by creating that library in such a way that we can supply this parameter here, it's the begin method down here that will eventually keep this or capture that to determine what we're going to do with it. And that's it. You've created now a library. So just to clean this up, we're going to take out that line there because we don't need it, because our test library does that for us. Now look at that. Nice clean code, all the complexity of the actual bit that generates this special number down here, and we're just doing some clever things here for controlling whether messages are displayed or not. And the header is the definition. Remember that the definition in the header doesn't actually do anything, it just says what is expected. Right, so your CPP must match what's in the header, but your sketch will look at the header to determine what's available and what isn't for your particular class. Okay, I think that's a very simple, and yes, it is a slightly artificial example, but even this one has probably given you a good idea of how to create a library. And in fact, I do urge you and encourage you to download this test script, test sketch, and just run it, and then you can play about with it and make it go wrong and find out why. Okay, so the things to remember is you must always declare your methods. Any method that you want available to your sketch, you must declare here within your public constructor. And of course your actual test library CPP file must include that method. Obviously it's got to do something here. Okay, and in your sketch, well, you just consume it like that, testlib dot whatever. That's the method. Can we go any further with this example? Well, let's think for a minute. Right, so there's one thing we can do here just to prove the point. Once again, it's an artificial construct, but let's assume now that our public method, the one that gets our random number, has to go and call another method that you've constructed, and it's quite a complex thing, got lots of lines of code in it, and we're going to call that a float get pi. Okay, so it's a method that doesn't have any parameters, but it returns a float, and it does in fact get pi. Okay, so in our CPP now we've got to create that one, so let's create it underneath this one, So we're going to say float get pi, no parameters, but we are going to say return 3.1415926. That'll do. Okay, close enough, isn't it, for pi? So instead of having pi here now, we're going to say get pi. So that this method is a private method only available to this class here. You couldn't call get pi here. If we tried to say testlib.getPi, the compiler would throw a wobbly and say, I can't find a public method called getPi, because we've defined it in the header as a private method and only available to your class. So this one here, private method for this class. Now you've probably spotted the deliberate error there. That wouldn't have compiled had we done it. This is testlib, right? Otherwise it'd just be a general getPi that isn't allowed. Right, let's compile that, upload it, see what happens. Right, that's uploading now. Let's go back to the window, see what comes out. And there we are. So the message is still coming out because we've said yes, we want it, and it's generating these random numbers, including pi. So it's obviously called our float get pi quite happily. So your public method, let's go to this, our public method get random is calling its own special private method of get pi, which is down here. And yes, we've still had to say it's part of test library because it is. Right, so that's how it knows where it is, but nothing else can get hold of this. So your sketch cannot use, no matter how much it wants to, testlib.getPi. And just to prove the point, we'll say, what was it, a float, wasn't it? Float test equals testlib.getPi. We'll try and compile that. Let me move this bit up here to make a bit more room for the error messages, which we'll doubtless get now. So we'll just compile it. And there we are. Look, it says error within this context. Is that it? There must be, oh, there we are, a bit more. Float test is private. It most certainly is. Let's go to the top. Right, starts at here. Let's move this up nice and big. Right, so it's saying in the loop, we're trying to call basically this method, and it's private. Float get pi. Error within this context. Can't do it. Simple as that. And that's good, because it means you can write lots of private methods within your library and only expose the ones that you want the user to consume and get a value from and stuff like that. Okay, so there we are. That sort of proved the point on that one, didn't it? That cannot be done. Let's comment that out. I'll leave that in actually and leave it in the sketch. It certainly is. Right, we're going to leave it there. I think if you were to follow this video start to finish, download the code, have a little play, you know that the code that's coming down the line will work. When you get it, if you play with it and break it, you can always download it again or just restore it from your copy. But I think it hopefully gives you a flavour of how useful even your libraries could be. Never mind all these big ones floating about the internet. Your own personal code could be made very much simpler and tidier by creating libraries of functions that you know are done and dusted and you just want to get them out the way, rather than just collapsing stuff up by clicking that minus that then of course does get expanded, I think, every time you compile or something, or every time you open the sketch up again. Put them into a library. Now you know how to do it. I think you'll see that you can move stuff over into a library and it will really benefit those more complex programs. Great stuff. I'm going to leave you with a couple of links actually, because if we go to the browser, let me bring my browser up. Now the library specification is on this one here, and I'll put a link into that. And there was another one. What else was there? Oh yes, keywords. Keywords. There's a nice little article here that explains it, but let me show you what that means. When we were creating our function here, all well and good, but when we try to consume it, you see that testlib, nothing shows you color wise that it's anything special. How do we get around that? Well, you create another file in the same place, and I'm actually going to do this in Notepad just to make it a bit easier. So let me just bring that up and I'll show you exactly what it needs. So on screen now you'll see that testlib is nice and orange, and it's up here, and get random number is also nice and orange, showing that these are recognized names, if you like. How did this happen? Well, there was a slight gotcha. It didn't work the first time I did it because, well, it would appear, I didn't know this, but it would appear that you can't do this if the library is local. It's got to be in the actual libraries folder. So what I've done is moved them over to the libraries folder. So let me just bring this up. Right, so this is just the file explorer in Windows. So I've created a file called keywords.txt along with these two that we had previously, but I've moved them now into the libraries subfolder. Okay, within the Arduino sketches, called it test library. It's got to be the same name, of course, as per your sketches. So the test library folder contains these two files plus now keywords. What does that look like? So here we have keywords.txt. Now the bits that are important, hash at the front means it's a comment, and here we have our keywords one, which are orange. Keyword one, so testlib, for example, you can see at the back here is orange, and both begin and get random number are keyword twos. So they are here and here, and if you notice they're still orange, unfortunately, according to the IDE, but they're not bold. So at least there's a subtle difference. Those colors, incidentally, are controlled by part of your preferences. You have to look at the preferences file, but don't do it when your IDE is open, because when you close your IDE, it writes back over the top of it. But that's for another day. Okay, so that's that. That's how we get nice little orange numbers. Remember, I had to move them into the libraries subfolder though for that to work. I don't know if that's just what I'm doing here, or whether it really is like that. Okay, also I changed the quotes here now to chevrons to make it, treat it more like a library rather than something local. But I haven't touched, of course, the underlying files. If you notice, the two tabs here now have gone because those files don't exist anymore. Okay, that's it. Right, that was a very short, well, I say short, let's say a brief introduction to libraries. It's quite simple once you've got your head around it. Once you've got a working example in front of you, I think it's really good. And then you'll suddenly, hopefully, see the benefit of moving your code into a library. Okay, great stuff. Hope your code improves dramatically as a result of this video. Thanks for watching, and see you in the next video. I hope you're finding these videos useful and interesting. There are plenty more videos to choose, and a couple are shown below. And if you'd like to subscribe to this channel, just click on my picture below and enjoy the rest of the videos. Thanks for watching.